Welcome to the second of several videos on how to solve trig equations. The goal of this video is to solve trig equations that are factorable or in quadratic form. So just like solving algebraic equations, there are several methods used to solve trig equations, and it's going to take some practice to recognize which technique to use when solving the specific type of trig equation. Again, in this video we'll talk about how to solve factorable equations in quadratic form, and I have other videos that discuss how to solve these other types of trig equations. So we want to solve each equation on the interval from 0 to 2 pi, including 0 and not including 2 pi, and then over all radian solutions. So the first thing, when we look at this equation, we have to recognize this as a difference of squares. Tan squared theta is equal to tan theta times tan theta, and of course 1 is equal to 1 times 1. So we can factor this just like we do in algebra, where we have tan theta plus 1 as one factor, and tan theta minus 1 as another factor. So if we multiply these two quantities together and we obtain 0, that means either tan theta plus 1 equals 0 or tan theta minus 1 equals 0. So if we solve each of these equations for tan theta equals negative 1, or tan theta can equal positive 1. Well, having a tangent function value of 1 or negative 1 should remind us of a 45-45 reference triangle, because the tangent of a 45-degree angle is equal to 1. So we can obtain a value of negative 1 based upon the quadrant we're in. What this tells us is our reference angle will be 45 degrees. Since we want to know where tangent theta is equal to negative 1 or positive 1, we're going to have to sketch a 45-degree reference angle in each of the four quadrants. Now we'll label each side of each reference triangle. First quadrant, everything is positive. The second quadrant, x is negative, y is positive. The third quadrant, they're both negative. And in the fourth quadrant, x is positive, y is negative. Okay, so let's go ahead and figure out what angles these would be. The 45-degree angle would have a tangent function value of positive 1, which is equal to pi over 4. The second quadrant would have a tangent function value of negative 1, so this would be an angle of 135 degrees, or 3 pi over 4 radians. In the third quadrant, this would be 180 plus 45, or 225. We'd have a tangent function value of negative 1 over negative 1, or positive 1. That'd be 5 pi over 4 radians. And lastly, we have this reference angle in the fourth quadrant. That'd be 315 degrees, or 7 pi over 4 radians. Now to come up with an equation that will express all solutions in radian form, notice how each of these varies by 90 degrees, or pi over 2 radians. So what we can do is start with, let's say, this angle, which is pi over 4 radians, and add multiples of pi over 2 radians, and each of these angles will be coterminal with these reference angles listed here. So we'll write plus pi over 2k, where k is some integer. Let's look at it graphically. Here's a graph of y equals tan theta, y equals 1, y equals negative 1. These intersections represent the solutions. So here are the ones that we found between 0 and 2 pi, and then our equation would give us all the other points of intersection. Again, they all vary by multiples of pi over 2 radians. Let's take a look at another equation. And this time we'll use a unit circle instead of reference triangles. You can use both methods. I like to show both at different times, but really if you find one that you like, you should stick with that. Okay, on this problem there's a common factor of cosine theta. So if we factor out cosine theta, you'd be left with 2 cosine theta minus square root 3 equals 0. So if we're multiplying these together, either cosine theta equals 0 or 2 cosine theta minus square root 3 equals 0. This one's already solved for cosine theta. This one will add square root 3 and then divide by 2. Let's go ahead and find our angles. Remember, on the unit circle, cosine theta is equal to x. So cosine theta will equal 0 here at pi over 2 radians. And now we want to find all of the angles that have a cosine function value of square root 3 over 2. Since this function value is positive, we know that we're going to be in the first or second quadrant. And so if we look at 30 degrees or pi over 6, we have an x coordinate of square root 3 over 2. So that's one of our solutions, pi divided by 6. And then we also have in the fourth quadrant 330 degrees or 11 pi over 6. Okay, to come up with an equation for all radian solutions, we'll start with pi over 2 plus multiples of 2 pi radians would result in an additional rotation either clockwise or counterclockwise, so that would produce all the coterminal angles for this solution. And then for pi over 6, we'd have to add multiples of 2 pi radians, and then for 11 pi over 6 the same, and again where k is some integer. So it's going to take 3 equations here to find all of the possible radian solutions. Okay, I think we have time for one more. And again, I'm using the unit circle here. It does come in very handy when we're dealing with sine and cosine, but again, you can also use reference triangles as we did on the first example. Let's go ahead and set this equal to 0 and see if we can factor it. So we'd have plus 3 sine theta plus 1 equals 0. So this is in quadratic form, so it does factor into 2 binomials. So we could have 2 sine theta here, sine theta here. Those are the factors of the first term. And then the second positions must come from the factors of positive 1. So we'll try positive 1 here and positive 1 here. Let's check it. The inner product is 1 sine theta. The outer product is 2 sine theta, which does give us a sum of the middle term. So either of these must equal 0. So let's set this equal to 0 and solve. So here we'll subtract 1 divided by 2. Here we'll just subtract 1. Okay, let's go ahead and see if we can find the correct angles to solve this. Now we want to know where sine theta is equal to negative 1/2. Well, sine theta is going to be negative in the third and the fourth quadrant because it involves the y-coordinate. And it's equal to the y-coordinate on the unit circle. So here we have a sine function value of negative 1/2. That's 7 pi over 6, or 210 degrees. And we should also have the same reference angle in the fourth quadrant, and we do, of course, 11 pi over 6 radians here. And for sine theta equals negative 1, the y-coordinate will only be negative 1 right here at 270 degrees, or 3 pi over 2 radians. Now for the equations for all radian solutions, we're just going to have to add multiples of 2 pi to all 3 of these angles. Again, where k can be any integer. Okay, so I hope you found this video helpful. Again, when we solve these, it is important that we use the unit circle or reference triangles to make sure we find all of the angles that would be possible solutions. I hope you found this helpful. Thank you for watching.